Hello everyone, let's wait a little bit until everyone joins us and then we will start. Okay, I assume that almost everyone joined us, and those who's left will join us later. So for now, let's start. Hello everyone, welcome to our today's session, and today we will continue our introduction to our course. Basically, first of all, we'll go through the review of the project we just set up in Eclipse last time, so quickly, just some basic things from there. Also, we'll take some steps from AutoLV, that's exercise 2. Then, yeah, so we will see some key, let's say, features of this project, what can be done there, and how does it look like. And one of these steps will be also the unit tests. We'll see how what the unit tests are and how can we use them in our project. Yeah, and as a part of this, we will take a look on the second activity 02 from the project. After that, we'll go through the setup go through the Git setup. Yes, those who come from the previous course will see. Will already know all these things we will do today, but to to do the setup for this course, we'll also need to have a repository, have a remote repository where you can share all the tasks with me, and also I can share all the logic, all the code with you. And after that, we'll go to the next topic, which is Java syntax. Again, for those who come from the previous course, this will be like repeat a little bit for you. Some new things will be here as well. So let's start. So here, and the first of all is the review of the project. So as you remember, last time we imported the project here. All the main things will be located under source main Java, and you can see there are lots of packages here. All of these, each package will is, let's say, linked to the corresponding exercise in Adobe. So we have lots of them. We have 14 plus extra exercises. So each of main activity is linked to corresponding exercise in Adobe. So it means that you will find the explanation of what should be done in the corresponding activity. First of all, you can find it right here, for example. If you tap on the activity, you will see to do link, and you can navigate from MacBooks, and this will navigate you to the activity, to the exercise, and here you can see what you need to do, and here will be the tasks, what should be done. So this basically we already almost done our first task. Some things yet to be done. First of all, we need to rename the project. Yeah, so you can do it as well. That's not so important, in fact, but we can do it as well. So to rename the project, please right-click on the project, press refactor, and rename. So here I need to actually need to generate the name. In fact, you can generate it where you want. That's not so important for us. I think in the web there should be the link here. A moment. Quickly check it. I think there should be the link where we can generate the name, but again, that's not so important for us. In fact, we can actually. One moment, let me think. I think we can skip this step. That's not so important if we just don't generate the name of the project. But if you want, maybe just to know how to refactor, how to rename the project, we can go to refactor, rename, and here we can, for example, I can add underscore and my name, and this will generate the name of the project. And also, since this is Maven project, we should also edit the POM file, which basically is needed for all the Maven projects, because this actually describes the main properties of our project. There are the errors, but these are not so important errors for us in the moment, so we can skip them at this point. Close this link. So yeah, and in POM file we can also see that there is a so-called artifact ID, which also represents the name of our project. So we need to change it to the name of our project. Yeah, that should be for the setup of the name. Yeah. So what do we have now? Yeah, just those who have not converted the project to the main project. To convert the project to main project, there should be, as I remember, configure. Yeah, that's under configure. So you go to configure, and here you should see convert to main project. Once you convert it to main project, first of all, since this is the project imported, you will already see a POM file here. But in case you create your own project, do not import. Then the POM file will not be available until you convert your project to main project. So yeah, POM file basically defines the properties needed for Maven in your project. And yeah, once you convert this to Maven project, you will also see Maven dependencies, which are so these are the libraries, the GARs, which come from POM file. That's why before you convert your project to Maven project, you imported the project, and you could see that you have the errors, the problems under your project. That's because some dependencies are missed. And to correct it, you need to actually load these dependencies, and after that, all the libraries will be here, and you can use them in your project without any problems. Okay, if you have any questions about this setup, please let me know. Yeah, now we're ready to work with our project. One thing here, you can see that there is Java 11 set. That's because this is the version of the project we imported, since this GTM was written on Java 11. That's why now we can see that the recommended version for this project was Java 11, and it is actually built using Java 11. So there's repository Java 11. That's not the problem if we use. So right now we downloaded Java 15, JDK 15 version. So this is the version I currently use on my computer. So in this case, if I have higher version, then I can easily use the projects of lower versions without any issues. Alright, so and now I have all the libraries here. The project is built. So yeah, if we go, so to see the, actually yeah, so as you know, maybe for those who don't know, to see how the project is built, we need to press on right click. We go to project build path, and here we go to configure build path, and right here we'll see the main building properties of the project. So sometimes you may have some issues here with the project build, so some classes may not be loaded. You may have the error in your project, and this will result in the issues. That's sometimes, most times, the issue comes from here. So it means that the project cannot be built because the build source, build path is not provided correctly. It's not set up correctly right here, and that's why you may have some issues. Yeah, so right now I have this Java test. I don't really need it, that's why it can be skipped. Main things are here, so Java main. This is this folder. So these are the activities, the classes I will be working with. Yeah, so that's about the setup. Yeah. Also, yeah, as I asked last time, you had to download and set up Maven. This will help you to load the dependencies here. So to check if Maven works, you can actually add the command Maven dash version, and this will show you the version we have in Maven. Just a small comment, as I mentioned last time, about how we execute the commands from console. Yeah, as I said, right here, if we type the command, then this will actually execute the program. Yeah, right. So as I said, we type the command, and this is the command located on your computer. So it actually executes. This is the file, executable file, which is executed. If we don't provide the path right now, this message is on my user. There is no such file there, but this is set up under the environment variables. That's why it can be accessed globally. And the path, as I said last time, the path can be found in the system variables. For those who use Unix-based systems, you can check it using echo command. And yeah, this will show you the variable we have here. And yeah, one thing to remember, so as I just said, these are the commands, and using the spaces. Yeah, so in the command line, when we use the spaces, it means that we provide the arguments to the command. So right here, I provided the argument actually. So if I do it this way, just for example, then it means that we provide 2 arguments. And this will this shows me the error because yeah, actually the arguments are provided incorrectly. But the thing is that if you use the spaces, then this means that these are new arguments. This one, open it again. So like in this case, for example, if I usually in the command lines we provide the path to any folder, and the common mistake may be if you have the folder with the spaces, like I have in this case, and maybe that will be something like this. So I use the command. Okay, in this case it works, but usually be careful with the spaces, because the spaces actually separate the argument and the arguments. And in case we use the spaces, it means that we provide more argument. In this case that works, but usually the spaces provide us these issues, and this means that this will be absolutely different command. So if we use just one argument, then the behavior is defined in one way. If we provide several arguments, then the behavior may be defined differently. So this is how the console works. And yeah, we separate the arguments using the command, using the spaces. That's just a remark in case you use the arguments, especially for those who use Unix-based systems like Linux, Ubuntu, also Mac OS. All these are Unix-based systems, and all these things have different property. All these systems have different properties than Windows. has. So in case you work on Unix-based systems, please be careful because some things work differently. Like the access to the folders may be different. Also, the slashes are different. Like again, if in Windows we usually use the slash from left to right. Then on Unix systems it's from bottom left to top right. So it's an opposite way it goes. This one should be careful. Okay, so once we set up Maven, we can convert the project to Maven. Also, how we can do it, and this is also mentioned in Adobe in this exercise tool, so you can check it out as well. Right here, it's also mentioned. Eclipse clean, Eclipse. So this is actually the command which basically does the same as here. If we convert it to Maven project, then everything is done automatically. If we use Maven Eclipse, so maybe I can quickly try it. Yeah. So here I have Java-13 or Java-13. This one. So if I copy address here. So the main if you work with command line, the main command you need to know is cd, which means change directory. So as you can see here, I provide the command, then I use space, and I provide the argument. So this is the argument I provide to the command change line. So it means that it actually changes the current directory. So if previously I had the directory C users, just my user, then right here I provide the command change directory, and it means that currently I'm working from this directory. So I'm located right here. So all the commands I will execute from here. It will primarily search for the files located here. Yeah. So this is what I have now, and I can execute command Maven. I can actually skip cleaning, I think. I can type Maven Eclipse. I hope that this was the right command. Yeah. So this actually, this command basically does the same as it's already done here. In case the Maven project, in case the project is not Maven project. In this case, we can also generate this these dependencies manually. So if we run the command Maven, again, as I said, this is the command Maven. I use the space, and I provide in this case I provide the actions need to be done by this command, but these actually the argument. This is the argument. Yeah, and so I call the command Maven. I provide the argument, and Eclipse means that we generate. We download the dependencies using Maven. And again, dependencies come from here. One more remark for those who don't know or don't remember about the projects. So we have the workspace. In Eclipse, again, that can be also the IntelliJ or any other IDE. We have the workspace, and under the workspace we have the projects. So in this case, I imported the project. I set up it here, and it is located in this folder. So all the files I have here will be replicated right here. Like POM file, it's also here. So this is just XML file with all the details. Basically, this is the same file. And also all the classes, if you just want to do any actions with them as with the files in your system, so you can easily search for them under, in this case, it's main Java GPM. and you can see that all the, so in this case you have GTM, and the packages here are displayed as GTM. So this is the first main package. Then we have sub packages, and sub packages are activity 01, activity 02. Here these two things are separated by dot. So as I said last time, we separate the sub packages. And right here under each is this package, we can also call it as the package. We have the files located under the package. So in case you want to do any changes with these files, just these files are located right here. Alright, so this is about and also the setup as I provide previous class pass, it is okay. The class pass setup and main setup main setups of projects of the project is located here also as an XML file. In this case, right here we don't see it, but we can change it using the build path right here. So basically what we do here, all the actions we do here, change the sources and so on and so on, is replicated in this file and is replicated this way. So all the things are defined here. Yeah, also the project settings, also the name of the project, so many comments as well here are defined right here in this file. So basically the whole project is set up as the folder of the files. So we have all the files which define the properties of the project. Maybe for some of you this may be clear, but this is the important thing to understand, not only for Java, but if we work with all the with any IT project. This again can be done on Java or any other language. Usually, if we have some settings, then you need to search for the settings in different files. Alright, so this is done, and yeah, in case you have any questions you can ask. I think that right now we've managed to have some errors, but yeah, these are not so important for us at the moment. Alright, yeah, so this is about the setup we have here. If you have any questions, then you can ask. Then let's quickly do the first task here. You can check what we need to do in Adobe under the second activity. Yeah, so I think this is it. So it shows that we need to create, using the generation, we need to create a hello class, and just one line here, system out print hello states not and something on unknown language. So that's activity 02. That's activity 02, and yeah, I will tell you what this file means. This will be a really important thing. But as it said here, we need to create a new class. So this is the class hello. Here we have public start. We check that we want to generate this main method, and right here I can easily paste this code, and basically this is it for this task, so nothing special here, just try it out. But what I want to show is this file. So under each activity, you will see so-called test files. Test files, yeah. So basically, every time under each activity, we have these tests or tests files. What these files are? As you remember, we can run the program if the program has main method inside, public static void main with the string arguments provided. Also, there are some exceptions where we do not need to provide this main method. Again, as you already know and we already worked, we can have the class. We can create a class which will be called from another class. And in this case, the class will not be the starter of the program. It will just be used in some other classes, which also can be called from, this main method, starter point. Yeah. And the second exception is the unit tests. There can also be the classes, like this one. It basically, in this case, it does not have any methods here. That's because it extends another class. This is binary class located here under GTM. Basically, it's wrapped. It's converted to binary class, and it is wrapped under gtm.gar library. The reason that is, in fact, yeah, in all the you can convert decode. Let's say we can convert, let's say, those decode binaries to simple Java code. Like in this case, if I open this GTM using any decoder, gdecoder, so I will actually see the original Java code. So this is the binary, and if I use so-called Java decompiler, this will convert the binary code to Java code. So this is simple Java code. It's simple, but this is Java code, which is used. In this case, all these codes are used for unit tests. You don't actually need to do any changes here, just in case you want to. Sometimes you need to look at this code. Maybe you also need to debug it, and this may help you. But in fact, what we can see here, so these are the files, and here you can see the same layout file, and in all other packages, you see such files, which are actually the files needed for unit tests. And right now, I can answer to the question what the unit tests are. So in this case, I created the file, hello, the class, yeah? And if what can I do with this unit test class? I can, again, the same way I can press run as, and you can see we have the option JUnit test. And if I run it, this will actually run the code. This will run the code, and this will show me what are the things done correctly. So these will be marked with this green tick. It means that the corresponding task is done correctly, and the activities marked as like this. These are the activities which are wrong or basically do not work as expected. So in this case, this was the test main 3, means that in this case, this unit test is maybe not the best example, but this activity is just the one we currently implemented. So in case, for example, if I delete this class, and run this JUnit test again, we should, we have 2 failures. And if we, for some cases this name and process is not reachable, but this is mostly technical. Connection to network, we do not have the connection to network because we have some restrictions comparing what is written here. Because, as I said, some things will be skipped from here because, for example, for Git, there is the common network they used in this course. If we go it over the head, so here we have the common Git network server, not network, so Git server. They used. We don't have the access to the server. That's why we just used the tools we can access to. And in this case, some unit tests, mostly the first unit tests, just because these unit tests are meant, these activities are meant for the setup, and that's why for these first 2 activities, the unit test will not be completely, we cannot completely make this unit test correct, the result of this unit test correct. But some tasks can be done, and for example, we skip the first one because we don't have any network and any connection we cannot set up because we don't have the access to it. But what we can do is the next activity. This is what I just done, and here we can see that there's the error, and we can read the content of the error. And what it says, it got error testing, hello class, Java class not found, exception. So it means that the class is not found. And again, if I create this class, maybe I can skip this creating of the main method. We will see what do we have at the result of JUnit test right now. There should be different error right now. So we can see that the error is different right now. So it does not say that we don't have this class, but it says that it says there's exception, no such method exception, which basically means that there's no such there's no method. You can see no such method. Java language Java.lang not such method exception, and we can see the name of the method on the right, and the name of the method is maybe we can also show this. Okay, we can show it this way. We can see that the name of the method is main. So the class name and the method name main. So it shows that there is no such method. So it means that I need to add this method to get rid of this error. So I do it. I create this main method. Just for those who did not work with Eclipse previously, so you can press Ctrl space and start typing main, and this will help you generate method automatically without typing all these things here. So I generated the method. Then I press here, from here, I press run JUnit test, and again I have the error, but now again I have different error. So I don't have the error which shows me that there's no such method, but it shows me that the output, there's no such output of the method expected. So as you can see, it actually shows you what should be printed, and it says that the method should print hello Sveicināti, but yeah, this is what is expected, but it actually received nothing. Yeah, that's because we do not print it what is requested. So if I print something, system out print, so for example I print hello, again that's not what is requested by this method, like by the unit test and by the requirement. What we have is something different. Again, we should have the error here, and basically it shows the difference. It expects hello Sveicināti, but it receives hello. So again, something is wrong. And finally, if we do as it is requested, so we just print what is requested by the task. So again, I run it, and now I should see that the test3 main is completed, no errors under this task, so it means that this this task is done correctly. Yeah. So basically, this is these are the unit tests. Basically, the unit tests themselves are the code, and this is the code, are the files of the code, Java code, which is needed to actually check how the program works. So basically, how does it work? It performs all the checks needed to verify if you completed the tasks correctly. So in our case, we will use it for the task checking, but again, in practice, it can be used differently, just to check if all the things work as expected. And in this case, the corresponding unit test under each activity will check if the activity is done correctly. So it means that we create the logic, like in this case, we created the logic here, and it checks if this logic works as expected, that we have the correct class name, that and if we have correct output. So in this case, these are all things checked by this unit test. But sometimes, and you'll see it later, that the unit test can perform more complicated tasks, complicated checks on the program done. Also, it can be the database checks. We will see it. The string checks, something similar we have right here, and so on. So checks are different. And yeah, as I said, we'll have these unit tests under each activity. And in your home tasks, when you're done with your home task, you can run unit tests, like maybe right here. So for example, activity 03, you will have the task random person, and then you'll complete the task here. So you complete all the steps defined here. Then you run this unit test, and you can actually see what are the things missed and what are the things which did not work as they should. And once you complete all these things, you should have normal. If in some cases there may be some exceptions that the unit test did not work as expected, not your code. And there may be the problems with unit tests. As I remember, with some activities, there is such problem. I will notify you if there is such problem with the corresponding activity. I will ask you to do. But yeah, I will let you know. But normally, in most cases, once you're done with the activity, you should have the unit tests to be green. And so you submit home task to me, and you will need to, you should also give me the print screen of the unit test, so I can firstly I can check that the unit tests are completed. So you have everything is correct, everything is completed, and there is no failures, no errors, no failures, and then this means that your task is completed. Yeah. So if you have green unit test, it means that your task is fully completed and you get maximum points here. If something is wrong, I can also check all these things and just maybe see where your issue comes from as well. So this is a really useful tool to quickly check what is correct and what is wrong. Okay, do you have any questions about the unit tests? So in case you have, please let me know. Yeah, so this is about unit tests, and we will use them during our course. Alright, so this is done, and the next thing, as I mentioned, I will set up Git. Most of you who actually work on previous course already used Git. Yeah, those who didn't, first of all, you will need to set up Git on your computer. To set up it, you need to use this link. Yeah, I will put it under links in our course. And right here you need to download Git for Windows. The download is quite simple. There should not be any issues. Once it is done, you will have two commands, git bash and git GUI. I mostly use git bash, and this is basically also the command line, which can be used for Git. Yeah. So once you set up with Git, then yeah, and also you can right now you can also check if before you start with Git, also check if your unit tests work correctly. I mean, you don't have any errors here. So if you just copy paste this project, then this code, then unit tests work as expected. So this just to confirm that setup of your project is done correctly without any issues. So please, that's quite simple. Please create this main method under activity 02 and execute unit tests. You should have the same result as I have here. So you should have the same. So just double check that your configuration is correct and your project is built without any issues. So please check them and just confirm that you have no issues. Alright, so once the Git is done, once you download Git, then you will basically you will be able to work with version control. And just as you remember, we use Git to manage the versions, to have the history of the code, to be able to push and pull the code to the remote repository, and and to manage the versions of this code. Also, you can share. So in the remote repositories, I needed to share the code with others. Okay, so I have some strange issues with all over. I think right now I have managed to solve them all. Okay, so now it's fine. And yeah, we skipped. We did not skip. We'll go back to the third topic, but before we go to the third topic, I'd like to open this Git setup topic because we need to set up Git to be able to normally work with our project. So yeah, please download Git, and what we will need to do is first of all, what I will do, and you will need to do for your repositories a little bit later at home, not right now, you need to create the remote repository. So we previously worked with Bitbucket. Again, if you want, you can use GitHub. That's also really nice. Basically, that's the most popular, as I know, the most popular Git sharing place where you can store your remote repository. So if you want, you can use GitHub or any other remote repository. That is not so important. I will use Bitbucket because I already used it. I use it in my local projects. So you can follow me and do the same. So yeah, I will create. What will I do? I will create the remote repository. So for those of you who did not work with Bitbucket, I will also share the link. So please register here in Bitbucket and create your account. So then you will need to create the project. So I have several projects here. Maybe I can create a new project. Just Java. You also need workspace. Java-13 lessons, and the project name will be Java-13. I'll type 2. So maybe I need to provide a key, description, if you want main project for Java 13 part 2. So I need to create this current project, so I create the project, and I will have the project where I will store all the repositories needed. So in this case, I will have 2 repositories. So the first one will be for this project. So I will do the activities from here. We will do the activities from here, and then you can see the code. You'll be able to see the code in the remote repository right here. So I'll create it this way, and this will be GTM. Yeah, I'll call it GTM. This is important for us. I'll not call Git ignore, and I will press create. So now I created the remote repository, and I will then link it to my local repository. Before we do it, for those who didn't work with Eclipse before, I recommend you to. So for Eclipse, we have such a nice tool called Git. So you can find it. Yeah, in case you want to download some new features, new tools for Eclipse, you need to go to Help and go to Eclipse Marketplace. And here you can find the main plugins used in Eclipse for Eclipse. So here you need to open it first, and from here you can search for some useful plugins used in Eclipse. So I have right here, so those who did not install it before, search for Git. Yeah, I already downloaded and installed it. So please install it as well if you don't have it. And this is basically this is the plugin used for Git tools in Eclipse. So once this is downloaded, you will be able to open such view for Git, and here we have more. Yeah, and again, if so, right here, what we have in Eclipse, we have the views. So this is the view where I can write the code. So here's the console. Right here, I can see the output of the code, the problems, Java, and so on. Here I have the view package explorer, and if you want, so maybe you lost any view or you need to add more. To add new views, go to show window, show view. If you need to take some to show some view from any view from here, then you can select it. If the view you want to open is not here, then you go to other, and here you can see the categories of the views located here. So again, I want to show something from Git, so it means that I go to Git folder, and here I have Git repositories. I need to have it, and I press it, and it appears here. Also, what I will need to use Git staging. So I select it, and basically it appears here, as it usually is here. So right now I have this view, this window for Git repositories. So this is the place where I can see the repository, Git repositories. As you remember, we have three main things here: our project Git repository, which is basically the local Git repository, and the remote repository. So once we do the changes here, these changes will be reflected in the local Git repository linked to this project, and after that, when we push the changes, then the changes will be reflected in our remote repository. So the first thing is for us is to create the local Git repository. So to do it, yeah, basically there are two ways how you can work. The first way is you can type all the commands in console. All the commands in console. Yeah, there's the question from Olga. I will ask you. Yeah, I will answer you a little bit later today. Yeah, I'll answer you, Olga. But yeah, so let's continue with Git. So yeah, we have two options. You can do everything from here, from Git bash. Here you can type the commands. If you check what we have here, open it. Okay, so it's fine. So I have the Git setup here, and the description, the things described here are the commands. So we have the commands here. Again, it does not work for some reason normally, but okay. So just in case you want to search for Git commands, you can simply type in Google Git commands, and here you can see some basic Git commands needed for Git. So here you can see the, yeah, maybe also, oh yeah, that's the Bitbucket support, also a nice thing to take a look on. And here you can see the commands which can help you to use Git. We don't really in Eclipse we have a nice tool here, so we do not really need to always work in Git bash using Git commands, but in fact what we can actually do is we can type all the things here, and this will actually mean the same. This means the same as what we type here. So if we type command here, actually we'll see that using Git tool we can repeat all these steps done with without using the commands here. But again, two ways. We can type these commands here for Git, and we can also do it manually from Eclipse. But I will mix it. Basically, the thing I like to do in Git Bash, it is, and from my point of view, it's easier, is to initialize the Git repository. So if I type git init, I will initialize the Git repository in my project. So I currently initialize Git repository, and I can actually add this repository to Eclipse. So here. So I will navigate to the project for the moment. Java. No, this one. That's the correct one. So, oh, sorry, that was incorrect. Sorry, my fault. For some reasons. Moments. So if I type git bash here, okay, I'm not sure, but okay, I think I executed git bash from here. Yeah, so be careful if you execute git bash from here. This will place will set the original place your desktop or something else. If you navigate to git bash from here, then this will navigate you to this place. Okay, yeah, everything is correct. Yeah, for some reasons that was placed in another location, not sure why, but okay, that's not so important. Yeah, right here you can see the location of the folder you are currently in. Yeah, and in this case, I'm under Documents, Java Lessons, blah blah blah, GTM Artus. This is this current folder. So now I'm here, and I type the command git init. This actually initialized the Git contents, so it is here, all the objects, all the versions placed here. One thing about the real projects, that's not only about Java, but in general, you have Git folder. Sometimes it may be hidden. It may be hidden, so you do not see it here, but it is actually located in your folder. So, for example, if you have a large project with the development done, say year by year, but with the large development done, for example, I can show you my current project. That's not Java project, but it also uses Git. Yeah, so this is my project, and it also has this Git repository, Git folder, and you can see that the size, what I want to say is that sometimes the size of this Git folder, if this is the large project, then the size may be quite large. And basically, in a moment, let me quickly check what's the size of the Bob. Yeah, basically you can see that the size of the whole folder is 1.5 gigabytes. If I navigate to Git repository, you can see that basically, yeah, Git folder actually takes the most part of the project. Yeah, this may happen, so be careful. Be careful, but just to know, when you use Git, it may take a large part of your memory in your computer. Yeah, so please be careful with it. And yeah, so I initialize Git repository here, and after that, I think that the easier way for us to work is is to work in Eclipse, and this is what I usually do. And so now I can see that under this folder I have Git Repository right here, and I can edit, and now I can see that the repository is placed here. Alright, okay, right now maybe let's have 10 minutes break, and after the break we'll continue with the Git setup. Okay, let's move on. So now we initialized Git Repository, and right now we can, and first step for us would be to link it with the remote repository. So what can I do is I will copy the link from here. I will not clone it, but I will just copy the link from here, and I will right click on here. I will I'll go to no, sorry, in here. Okay. Remote. Oh, no, sorry. We go to branches and we have remote tracking. Sorry, no. Here we have remotes. Yeah. We have remotes here. I type create remote, and I select origin. Then I provide the URL. So the here, for you'll need to, those who doesn't have it, you need to provide username and password. To be able to connect to your repository, then you press finish. And what can I do? I will just save at the moment. Then I will stage all the files I have here. Yeah, so you have staged and you have unstaged changes. As those who doesn't know, unstaged change means that these changes will not be reflected once you commit the changes. So we have commit before we push the changes. We commit the changes. These changes will be tracked locally in under your local Git repository, but will not be pushed yet to the remote repository. So once you stage all the changes, you can commit them. It means that these changes, type it first commit. So these changes will be committed under the local repository. So I tap commit, and these changes will be reflected here. So I have this commit here. Okay. I have this commit here, and this is the repo. So yeah, now I can push changes. I think so. Since this is the first push, it may trigger some issues. Let's see if I don't have such. Maybe I will have, maybe not. Let's see. Okay, I do not have any issues. Don't have any issues. And if I refresh, I should have all these files here. Yeah. So I have all these files here, and yeah. I will also share this repository with you. But maybe I will do it after the lesson. So I will add your emails here, and you will have the invitation, and so you'll have the access, reading access to my repository, where I will share the tasks we do together here in class of the activities. Also, we'll have I will use two projects. So this is the project for the main task, and I will also create another project called examples. Yeah. Called examples, and so this is the project where I will show the activity. Well, I will do the activities with you, these activities, and this is the project where I will show them some code examples used for our course. So I will do the same. I will create a remote repository here, first of all. Java-13-2, this one. Create the repository here. Another one. And I will call it code examples. So this one will be file repository. Yeah. So I'll create the repository here, and I will basically do the same steps. I will go to code examples. I will. I don't need Git bash here. I'll need it here. So now I have the Git bash with the current folder, which is this folder. So I can initialize Git repository here. Git repository appears again. This may be check your settings, your folder settings, because usually Git repositories are hidden folders, and you will not see them if you do not enable the corresponding setup in your folder. So once it is done, again, I can do the same steps here. I can add this repository here. So that should be in this folder. So I edit, and I will add remote right here. Here. So this is the path of the remote repository. Here. Save it. Then I will commit all the changes, tap the message. You can also type commit and push, or you can also press on commit and push. So it's on board in our case, and now I push the changes, and yeah, now all the changes should be here then, and we will use this. I will use this repository to share the code with you. So here I will write just some code examples we'll have during the lessons in our course. Alright, so Git is set up at this point, and again after the lesson I will show the I will share the access to these folders with you. So for those who did not participate in the previous course, so please share the email with me, your email with me, so I can share access to the repository with you. Right. So, in case you have any questions, please ask. Yeah, here you'll find a different setup, but firstly, that's related to the server, but we don't have the access to the server. But all the other steps, here you have Git pull, Git commit. But again, in our case, we done it manually. We done it in Eclipse. Basically, again, all the same things we done here. Git stage, Git commit, Git push can be done using Git commands like these commands. Git pull, Git add, Git commit, push. If you want to do it using the commands, you're welcome to do it, but it's easier to track all these commands and to execute all these commands using just clicking all these things here, from my point of view. If you think differently, you can easily use Git commands directly from Git bash. That's not the problem. Yeah, also, just before continuing, we have one branch. That's the master branch. This is the topic related to the branches. We will talk about we'll talk about branches in the topic about remote versions. This is one of the topics we have in our course. Let's check it. It was somewhere at the end of the course where we will discuss the remote repositories, the Git tracking in more details. We will talk about, okay, this is something, there's something wrong with Adobe today, but okay, of course, yeah, we'll have it at the end of the course. We will talk about Git about Git in more details. We will talk about branches. Yeah, also there will be some more things related to the project work, also related to Git. We will discuss them, but again, because at the moment we just the main things we will need to use is to put the changes, pull the changes and push the changes. The pull is, yeah, also the pull will not be so important for us. Just aim is push the changes to share the code with others. And yeah, also the task for you is to create your own repository, a remote repository, and share it with me. So this is only one repository, GTM, where you will share the home tasks done with me. So basically, please do the same. Create the create local Git repository and remote repository, and share it with me. So how to share it? Again, go to your repository, then go to repository settings. Then you will have user and group access, and then right here, please add my email and give me read access. Yeah, I don't need other access. It's here, just read access. So then you add me, and I will receive the invitation to this to access this repository. So I will be able to access it and to see what is done by you. Right, okay, so that's about Git. We'll use in our course. In case you have any questions, please let me know. But yeah, for now I think that's all I wanted to share about Git. So please do all the settings. If you have the issues with the setting, just please do contact me. I will help you. And yeah, so right now let's move to the presentation. Again, for those who work in the previous course, some things will be familiar. Most of the things you already know, but again, repeating will not be something which you don't need. This may help you. This may always help you. So yeah, right now we'll talk about some key things in Java syntax. Yeah, the keywords, all the operators, statements, blocks, identifiers, primitive data types, how to comment code, different types of comments, decoration, initialization of variables, and typecasting. Today we'll not talk about typecasting of the reference types, but just casting of the primitive types. This is the thing which is called the same typecasting, but it works differently for the primitive type and the reference type. So we'll see it in our course. Yeah, scope, the variable scope, the living scope of the variable, then conditions and branching, reference variables, the arrays, operations with the arrays, some utility classes, and code guidelines, which is also a really important topic. This is the one we do not widely discussed in the previous course, but this is also quite important. So let's talk about all these things. Yeah. So the first thing is what basically the code is. We write the code, and what the meaning of this main task is to process the data. Process the data and control flow management. So usually, what do we have? We have the data stored somewhere. It can be the database, just anything that can be the files, and also like if we have the application or the website, it doesn't really matter here. Then you type some data in that can be the website or the application. So you have some input fields. There you type the information there, and you actually provide the data to the program. So again, it can be also right here. So we have PowerPoint, but PowerPoint is also built on using the programming language. So right here we have search, for example. This is also input. So we provide right here the information, and this information is processed by the code. Yeah. So this we provide the information, and it is processed by the code. So this is data processing. Also web development. The input we provide. There also the button clicking, like we click on the button. This is also actually data processing. We actually we give the signal to the program that we pressed the button. Yeah, so it can be like this button or any button. When we press on the button, we give the signal. We provide the data that this exact button is we pressed on it. And this is also kind of the data processing. Yeah. We provide the information, what is done. Yeah, so we pressed on the button. Yeah, and the second point is control flow management. So we have the list of the actions done and how we need to process all these actions, all these data. Yeah. And then the elements of the program are this data. Yeah. So just set then the statements which process the data. So this is what is done using the code. The comments which do not affect the code, the behavior of the code, but comments help us, I mean developers, to understand what is written in the code, and just it's really important. It's usually important to use the comments, but that's actually a quite interesting topic to talk about. So there are different types of commenting in the programming, and it's also when we talk about the comments. So sometimes you may ask, or other people may ask you, what's basically the how should I comment the code? Yeah, what is the way I need to comment the code? Like I write the program, then how do I need to comment what I just written? How it's necessary to comment it? And the answer is there's no answer. There's no answer because it depends. first of all, it depends on the main place. It depends on the project you work, because in some projects, in some tasks, I would say projects usually call the scope of the tasks we do project. We name it project. So yeah, in the projects, in different projects, this the commenting rules are different. Like sometimes when you do the changes, you should write type your name, surname, username, and all the such data. Some reference changes. Some references to the change for example, the tickets requested. There's the request for the change. Then you need to provide the ID of the request of the change. So sometimes you also need to provide it in the code. Like sometimes you should also point where is the beginning of the changes, the end of the changes using the comments. Also, you may be required to, you may be asked to point which lines are changing, like you add the line of the code. Just show an example right here. So here. So sometimes you have the code, then you write some additional line, then you need to write something like this. The line is added by, so I have the name, or some username again, it depends. And sometimes you are asked to do some such comments, like if you add the line, you need to point that this particular line is added. But again, this depends. It depends. Sometimes you need to write such comments like start of insert, information, and of insert, such information may be required in a specific in your project environment. So please be careful what is requested, because sometimes there may be strict rules requested by the technical leads. That's just a small topic outside the main scope, but that's really important information to know, because the comments are this is a really important topic, which can be quite serious in the project you're working on. And yeah, white space is also the part of the program, because technically white spaces may separate. Technically, they separate some keywords. Like saying when you write the code, basically, what happens when you write the code? When you write the code, the compiler actually just checks if you have the correct. So if you have in this case, I type public. Then the compiler checks, okay, I have PUBLIC, yeah, I have this, so this is the keyword. It recognizes this keyword, and then maybe there's some other keywords which starts with public. Okay. There's no such keywords in Java, as I remember, but sometimes there may be the keywords which are the part of another keyword. So how do the compiler understand where the keyword is fetched? And in this case, the keyword ends. And in this case, not only in this case, but in all the cases, using the spaces. In this case, there's the space which points to the compiler that here is the end of the keyword. So that's why white spaces are quite important. They are not so important in Java, but in Python, for example, also I mentioned last time, ABAP, there's such a language, SAP ABAP, there's a huge meaning of the white spaces. Because sometimes there may be, like in some languages, I will show you, if you type something like something like this, maybe something like this. This may be not the same as if you type something like this. You add two spaces, then there's absolutely different meaning of these brackets. There may be such possibility, not in Java, but in other languages. This is what I would like to say, that white spaces may be quite important, and the role of the white spaces sometimes may be quite important. So if you switch between the languages, be careful that the languages is not so space sensitive. Just to be sure. All right. So in Java we have different keywords recognized by compiler. So it means that you cannot name the variables as the keywords. The keywords are needed. Keywords are used by Java language, and they provide the meaning for. They provide some properties. Properties are also the actions done in Java program. So we have some keywords for Java file structure, the package to define the package, the class or the file actually is located in, then the import to provide which libraries are used in the current file, and the class where the points start to the start of the corresponding class. And num, I think we did not talk about nums before, or we did, I cannot actually remember, but also specific type of the class, the interface where the constants are stored, then the interface type of part of object-oriented concept, object-oriented programming language concept. Then for inheritance, we use extends to extend the class, or implement to implement the corresponding interface. We have the loop, the keywords used for conditions and branching. So this is if, else, standard keywords used in practically all the programming languages. For the loops, so for the loops we use for, while, do. Break to finish the loop. In some language, in Java it is break. In most languages it is called break, but in other languages break may be replaced with exit. So if in some languages you see exit, not break, then the meaning may be the same as for break. It actually means that we break the loop. And so if you have the loop for into something, and we usually loop until all the conditions are fulfilled. In for, that's the second position, and while that's what we provide inside the brackets. But if we want to go out of the loop in any at any point of the execution of the program, then we need to break. It means that we go outside of the loop. Continue, it means that we go to the next iteration to the loop. So I think we did not use it quite often before, but it actually means that we do not go, like that we have the beginning of the loop, and it's for some conditions, start of the block, end of the block, and then we have some logic in the middle. If you want to skip processing the logic at some point, just go to the next iteration of the loop. We need to use continue. We'll use all these keywords a little bit later, don't worry, but this is just saying how to use it. Then we have switch based on one particular value. So we'll have switch, and we have have the switch, and we have the cases of the switch. Then based on the cases we do some actions. also the part of the switch statement. Default, if none of the cases occurred under the switch, then it goes to default. Return, when we are in the methods, then return, it actually has two options. If the method has the returning parameter, then we need to provide the value returned from the method. If the method does not have the returning parameter, it means that it's just a void. Then we just go out of the method, or if we are in the main method, this will actually finish the execution of our program. So this is really important. Keyword, which if you see it, it means that at this point the execution of the method may be finished. Yeah, so if you have something to skip in your logic based on some conditions, then we can use return. Right, then there are the keywords used for exceptions. The basics are try catch. It means that inside we have the block try, we have some logic inside, and when we get the exception there, and the exception is the definition of the exception is provided under the catch, then catch block, then it means that the exception will be handled there, and under the catch we can process the exception period. Finally, that's also the part of the exception block. We'll talk about it mostly in the topic about the exceptions. We'll have the topic throw, to throw the exception, and throws to point in the definition of the method that this particular method actually throws the exception. So this there's one S letter, but it points to the meaning of these two throws, and throw is different. Throw is needed to throw the exception, means that we will raise the exception, and throws means is needed. Is needed to point to the point that the particular method actually throws the exception. Yeah, so this is used for method definition. This is used inside the call. Then assert, I think we did not talk about assert method before, but this is needed mostly for the development and testing purposes. Again, we will have some tasks and some examples with assert later, but just in a moment to let you know. Also, the unit tests used this topic mostly usually use assert statements. Yeah, like here. Okay, maybe they are used in a different way, but okay. Yeah, okay, maybe you will not see the sort keyword right here, but the meaning is that this provides the error. So basically, using assert, we can check the condition, and if the condition is if the condition fails, then we get the error. And I mentioned that it is mostly used for the development purposes and is not usually used in the production environment. So this is a unique, not say unique, but quite unique keyword, which the behavior of which belongs, but it depends on the settings we provide to the program. So, and usually it means that if we have the program somewhere in production, so meaning that it is used by users, then the assert statements are skipped. So usually when you have something like assert something, but if you have assert statements in your production program, so it means that this is used by users, then the assert statements will actually mean nothing for the program. Like, I'm not saying like the comments, but they will not affect your program. But in the development environment, usually we set the execution of the program in the way that assert statements are considered, and it means that if the assert statement fails, then you will have the assertion error. So why it is needed? It is needed to check the issues during the development, or again we can set it up somewhere in the testing system or in development. We can set it, and if we want, we can check some conditions. Yeah, this is understanding of assert statements is also important for understand how do we develop things in real life. So as we know, we write the code, then the code is usually deployed to the production. We call it production, I mean the real product we have, like the website, the application, and so on, used by users. So usually how do we work? We have a development system, we have the testing system, and we have the production system. So we usually have these three different systems. Again, it depends on the project you're working in, it depends on the programming language you use, but usually, and the common approach is that we have these three stages. We do the changes in development, we test the changes in the testing. It can be called migration system, it depends. Yeah? Testing, migration system, quality system, yeah, it can also be called this way. And once changes are tested in the testing system, in the migration system, quality system, then after that changes are confirmed, the changes work as expected, then we can move all the changes to production. And yeah, so why it is needed, I think that's quite understandable. That so when we do the changes, do not affect the testing, which may be currently ongoing in the migration system or in the testing system, call it this way. Do not affect this the testing. Then we need to separate these two systems. Okay? Because again, during the development you may have some bugs, some exceptions, some errors, and just to not affect the testing, we do not we want to deploy the changes before we are done with the development. And then, of course, we have the development stage, development system, where the changes are deployed from the development. So it means that development is done or partially done. It depends, and we are ready to do the testing. We move our changes to migration, to the testing system, and right there we usually have the real data. Yeah. Real data, but the data which is quite similar to the real data we'll use in production, and with all the real data we can test all the things there. And once the changes are confirmed, everything works as expected, changes are moved to production. And in these cases, to distinguish some to change the behaviors logic of the logic, where we need to test if there are some serious, or I'll say quite serious issues, then we use assert statement. And in this case also, when we have what happens when we have the bugs, the issues. I would say if we have the issues in the development system and also in the testing system, so it's really good. So we can we see that, okay, here I have the issue, I can investigate it, and I can solve it. Like if we have the issues on the development stage and on the testing stage, it's quite good that we know that the issue is here and we can check it. So in this case, for example, we can do some checking, some additional checks, and using assert we can understand if there is or there's no error. But if we have the issue in the real system, in the production system, I mean, then in this case, as you can understand, that's quite serious problem, because we work with it can be customer data, and for example, imagine if we have the code which processes the payment, for example, yeah, then imagine that there is the issue in the code which processes the payment. Yeah. I mean, if this code fails or it breaks or something like that, this may cause quite serious issues. In real life. That's why before we do any changes with such logic, we need to be sure, and in some cases assert can help us. Yeah. This is shortly, but the little thing for understanding how the testing is done, and in some cases we need to enable assert to actually check some additional things. If we do not enable assert, then enable the handling of the assertion errors, then assert statements will be ignored, in fact. Alright, so this is about assert and primitive types. So these are the primitive types in Java: Boolean, character, byte, short integer, then integer, long. This is long integer, and then we have the numbers with the floating decimal characters. So the decimal numbers, decimal digits, decimal numbers. So these are float and double. Okay, next one, to construct and to use the objects. We use new to create new object. This to access the object we are currently in. Super to access the methods and also the constructor of the super class. Instance of to check if the current object is belongs to the class or to the super class of the class provided, or the class or the interface provided on the right. So it means that the class on the left can also implement the interface on the right, and to check if it's true or false, and if the object on the left side does not implement the interface or is not the class of or the super class of the class provided on the right, then that's result into false. Yeah. Access modifiers: public, protected, private, and default. There is no default, but actually default means nothing. Just you do not provide any access modifiers. Modifier, it means that this is default. Then we have some other modifiers: abstract used for the classes, like abstract classes or abstract methods, which are the abstract methods of the abstract classes. Final, used for the constants and for the methods and for the classes that cannot be overridden. Static, used for the static attributes or static methods. these are synchronized translate load to your native, and strict FP. These are less used, and yeah, these are more specific. We will not touch them in our course. Yeah, the voids, these are just the methods which do not return any values, and the keywords which are not used anymore, constant and const and go to. Okay, so right now maybe let's have 10 minutes break, and after the break we'll move to the operators. Again, let's continue. So, in Java we have the operators, and in fact, yeah, these are basically the functions, not the yeah, they're called the methods, but in Java in programming we usually call the methods just part of the classes, but in this case, yeah, we can also call them the functions, the methods. Well, yeah, with some specific syntax, and we can also we can split them in different groups. We have arithmetic operators used for counting, I would say, for numbers. Bit shifting operators to shift the bits. Maybe not usually done, but not usually needed to be done by just using simple and most used actions. But yeah, also there are such operators for bit shifting, comparison operators to compare the values, and yeah, these return arithmetic operations return us the result, like numbers. Bit shifting just shift the bits in the variables. Comparison operators return us true or false. So it means if we use the comparison operator, we compare if that's equals or maybe less or greater than or not equals, based on the operator used. How we compare this returns us true or false. Yeah, and also the logical operators. These are quite same as comparison operators. These are maybe the group of the operations which at the end return us true or false. If the logical expression is true, then it returns true. If it's false, then it returns false. Assignment operator, that's if this is the operator. It's actually one operator. It changes the value of the variable. We assign the value to the variable. And conditional operator. These are the operator based on the conditions. But yeah, let's quickly take a view on them. So we have the brackets, rounded brackets needed for the methods. Using the brackets, using the rounded brackets, we can declare the methods. Basically, we provide inside the brackets. We provide the parameters to be used in the method. If there's no parameters inside the brackets, then just leave them as is. And if we call the method, if we use them inside the code, then it means that we call the method using the rounded brackets, like method name, and then we provide the parameters and using these brackets we point that method is called. Then square brackets used for the arrays. We access the arrays, and we also create the arrays using the brackets, the square brackets. Yeah, so nothing more to say here. And then dots used for class accessing, or like if we have the method, the objects, then we access the methods or the attributes. So this is also called dereferencing operator. So it means that we dereference the object. So we can access them to the attributes and the methods of this object. Yeah, in Java we use dots, but in other languages you may also see, you can see this bullet. This basically will mean the same as the dot in Java. So in other languages we use bullets. In Java we use dots. So in case you switch to another language, so please so you can check if most likely if it's not Java, then this will be the bullet. But this means the same as dot in Java. Then we have the operators which look the same, but based on the place we put them, the behavior will be different. These are postfix, increment, and increment. So it means that we can place this these two operators after the variable. So this should be numerical variable and integer variable. And it means that we increase, if we have pluses, then we increase the variable by 1. If we use minuses, then it means that we decrease the decrement, the variable by 1. And we can put them into places before the variable or after the variable. And maybe a short example here. Yeah, I'm using the packages. And source folder. Okay, I can create this source folder. Source and operators. Examples. And the method here, and we can see, so we have the variable, the integer, so we type simply 3, and then I'll use system out .1, and I have two options. So I can do it this way. So this is called postfix increment. So what do I do here? Run program, and I can see that I incremented, but I used the postfix increment. So this means that first I use this variable in this as the parameter in this method. The value is used, it printed out. Once after it is printed, after basically the value is passed to the method print line, then the postfix increment operator is executed. So it's executed. So it means that we will print value which was stored in this variable before the method is called. And after that, so once the execution of this method is finished, then the variable a is incremented by 1, so it's 4. If we do the same with the prefix increment, then it means that the plus the variable a is incremented before it is passed to the method. Okay. So the same as with minuses. So in fact, the operator looks the same, but the actions done by this operator are different, right? Then yeah, we have just plus minus to add or decrease the value of the variable. And yeah, so here we have logical not and bytewise not. So but bytewise I will not tell much, but yeah, logical not means that if we have the variable or the operation which returns true or false, then like if we have true, then we apply this not operator. It means that if we have true, then we have false, and if we have false, then we apply the opposite operator. This will return true. And if we have false, we apply not false means true, not true means false. Then we use, if we use the brackets, we provide the type inside the brackets. This will cast to the type. The type we provide inside the brackets. Yeah. Then we use new when we want to create the object, and the object may be the instance of the class or the array. Then yeah, we have multiplication, division, and reminder or module. So using the star we multiply two values, two variables. Using the slash we divide. And using the percentage mark we get the module. So it means that, for example, module. Those who should not remember. So it means that we have A. Let's say we have B. It's B13. So it means that we divide. So we have B modulo A. Means that we divide B by A and see what the remainder is. Comment, so let's keep B modulo A equals that's 3, because we divide 13 by 3, so that's 12, or sorry, that's 3. Sorry. Individual. So that's So that's 13, we divide by oh, sorry, oh yeah, my fault. Yeah, A is not 3 anymore, that's 5. No, so maybe it's, yeah, I just forgot that A is 5 at this point. So it means that we divide 23 by 5. In this case, that's 5, and this should be 3. Yeah. That should be 3 because we divide 25 is divided. So it means that we divide 25 by by 23, or sorry, not 23, but oh, sorry, 23 we divide by 5. So this is 4, and plus fractional 3/5. Yeah. So, and we just get using the module, we just get this number, which is the remaining part of the division, b by a. That's most we used. That's quite. It's maybe I would say it's used in some cases more often than the multiplication or the division is used, because it's quite basically where we mostly use modules and why we use them, and what is the gold, I would say, the gold property of the modules. When we use basically, how usually we do? We have the number, and we need to do something with the number, and like we have any number b in this case, and we have we may select fixed number of a, fixed number a. How can we use modules? First of all, maybe we can split some input values into the groups. So, for example, we have a set of numbers, like any 10 numbers, and we need to, based on the value of the number, we need to split it into the one of let's say 3 groups. And in this case, and the position of the group may be 0, 1, or 2. And how to get the number of the group? The most simple way is just to get the modulo of the number divided by this number 3. So it means that we can provide any integer number if it's 1, 2, 3, 4, or just even more than 1,000,000 or 1,000 or something like that. When we divide, when we actually get the modulo of 3, it means that remaining part may be only 0, 1, or 2. It cannot be something else. So in this case, we have the restricted, the output may be just one of these 3 variables, or one of these 3 values for any number provided. And yeah, this is quite important for the grouping. Like if we have hashing, we need to hash our values into different groups. Then we mostly use modulo. Also for in cryptography, that's used very often. Okay. That's about modulo. Yeah, plus minus. Yeah, just adding the subtraction. String concatenation. Also, if we use the plus for the numbers, then it means that we just add one value to another. Yeah, we just sum 2 values, and we have the result. If we use plus for character or for strings, then it means that we can concatenate 2 strings. And in Java, that's okay. That's quite simple. But in JavaScript, if we work with JavaScript, then it may trigger some interesting things. Just show it here. JavaScript. Moment. Yeah. So there are many memes about JavaScript, but yeah, in Java you need to be careful. In JavaScript, when you use JavaScript, then you need to be careful how you use pluses or minuses, because it may be quite sensitive if you use them incorrectly. So, for example, if you use, in this case it's not shown, but okay, that's better. So sometimes JavaScript, when you use minus, it will always act like you work with numbers. But if you use the plus, then for the strings it will concatenate the strings. So in this case, need to be quite careful. This is what I faced sometimes with JavaScript, and that you can use plus, like you have the same source for the variables. Then you want to, and I want to sum the variables to add add a fixed value to the variable. Then in JavaScript, this I faced some tricky things. If I use plus, so one variable A plus variable 2, then I get concatenation of the string of the variables of the values I used. And then if I used minus, then that was just a simple mathematical subtraction. So in this case, need to be quite precise when we use it in JavaScript, but in Java we do not have such issues. Such a simple plus for strings, we can only use pluses, and it does not do any automatical conversions there. Okay, then we have these strange bitewise shiftings. In case you want to perform any operations with the bytes or bits, with the bits, then you can use these operators. We will not use it at all, of course. You can get relational operators, less than or less or equal, or greater than or greater or equal, equals or instance of, as I said, return true or false. Also a comparison operator, so if it's equals or equal to or not equal to. Then bitewise logical AND is for bitewise operations, and we will not use them. What we will use is a simple logical operator, conditional AND, and logical conditional OR operators. And this is, we have this conditional operation. It's mostly called new syntax. Have expression true or false, which returns true or false, and then we use question mark, and we have two options. If the condition is true, then we do the action. When we perform the action defined here, it will be true. If the condition is false, then the action performed after the column is performed. Assignment operator used to assign the value. Plus equals is the shorter version of how can we add the value to the variable, and how can we subtract the value. Variable, the same as for the multiplication, division, and the modulo. Then for bitwise shiftings, also these operations can be used, and also for AND, XOR, or also these operations will be used, but we will not use them in our course. So about arithmetic operations, so these are the operators used for arithmetical purposes. I mentioned all of them. Same is for logical. Returns true or false. So if we work with the logical operators, you can in fact combine them into one statement which returns true or false. So in this case we have two statements which return true or false. So this one returns true or false and this one returns true or false, and we combine them using logical AND operator. So in this case we get one large statement which returns true or false. So we can combine them. It will have AND. It means that both conditions should be false to make the both statement false. Should be true to make the both statement true. If one of the condition is false, then it means that the both statement is false. If we use or in between, it means that one of the conditions needs to be true to make both statements true. So just like you speak in real life. So we have one or another. It means that one of these two. That means one of these two. If we have one and another, it means that both at the same time must be true. So just in real life, like you say all these things, then in programming, these things are the same. What are you saying? In the same way. Yeah, and here we can see how the operators work. So if you just add the assignment operator and then the operation used, then it means just a simple add something, like in this case add 3 to x, then subtract 3 from x, and so on. Then for bit operations, we will not go through them precisely. Just really to know that such operation exists. We can represent the numbers in bits, and using these operations, we will also have the output based on the values provided. Like in this case, we have minus 128. We use right shift, and this will result minus 16. So there is the calculation done under this one. I do not want to go deep here because it is not so important for us. We can check how this is done from this schema. We just shift the bits here. Yeah, so right here, for example, we have shifting by 5 bits. So we have the number 1357 represented in bits. So it's represented this way. So we have zeros, and we have 1, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, or 1. And if we shift right by 5 positions, it means that we just shifted by 5 positions to right. Means that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it means that 1, 2, 3, 4, 5. Yeah. So it means that this will be 0, 1, 0, 1, 0, 1, and yeah, this is 0, 1, 0, 1, 0, 1, and all the zeros after that. So it means that we just shifted our sequence of bits to right. So So, and the same as if we do it on left. Yeah, but yeah, that's not so important for us. We will not use it in our tasks. Yeah, comparison operators, just to compare two variables, and this will always return the boolean, means true or false. Yeah, so you can also, to control the order of the operation executed, you need to, we usually use the brackets. So using the brackets, we define which operation to be executed as the first one, which as the second one, and so on. So we use it. Then, we have statements in the programming. So it's called smallest standalone element that defines executable action. For example, we have some statement which actually represents us the action done. So we can assign something for something, and we can print something, we can do any actions using the statements. And after statement is done, we put the semicolon at the end. So it means that the statement is finished. We do not need the semicolons for the blocks. Like we have the start of the block, end of the block, because that actually defines the end itself, so we do not need any colon. But for any actions done, we need to, like, if we assign something to to the variable, then we need to use the semicolon at the end to define that, to point that the statement is finished. And as I already mentioned, the blocks, we use these curly brackets, and this points us to the start and to the end of the section. It can be the class, it can be the interface, can be the num, can be loop, and so on. So many different things can be defined with blocks. Then we have the data type, data types, and we have in Java we have two types of data types. There can be primitive types and objects, or we can also call them reference types. Primitive types are just literal, so constants or the variables. Primitive variables, like integers, characters, and booleans, or any other numerical values. And the objects, built-in objects, and custom objects. So these are the classes, the arrays, the interface, the dynams. So these are the objects. So something which is more complicated than the simple variables. And in fact, the reference types wrap the primitives inside. Like the classes are built from the primitives. So we have the attributes. So we define the attributes as the part of the class. So it means that we wrap the attributes inside the classes. Like the strings are also the objects, and so as we know that the strings are built from the characters. So that's basically the string is just the sequence of the characters. So we can also call it the array. The array will have exact position of the character in the array, and basically the string is the collection of these, the sequence of these characters. And yeah, this is basically how can we imagine the objects. These are the objects contain the elements inside. Identifiers, the names of the elements, name of the methods, names of the methods, names of the variables, the constants, and so on. So, it should start with Unicode letter underscore or dollar sign. To be honest, I never seen that in Java. Java used dollar sign. Oh, yeah, we can actually do it, but yeah, it's maybe not so usually used. If you work with such languages like PHP, in PHP we should always use the dollar sign as to declare the variables. That's just a specific thing of the language. Yeah. But yeah, in Java it can be any Unicode letter, underscore or dollar. Yeah. By convention, variable starts with lowercase letter. Yeah. So this is naming convention. So please note that naming conventions are not mandatory, but highly recommended. And again, it depends on coding style, but that's how coding in Java happens. That we use. That we start variable names with lowercase. That should always be this way. We do not declare variables this way. Integer. We do not declare. The variable name should not start with the name of the variable should not start that's about variables. Should start with lowercase. Yeah, so variable names are case sensitive, so it means that we can declare the variable a, and we can declare var a. So these are two different variables. This as var a. Two different variables. Case sensitive. There are the languages where the variable names are not case sensitive. There are such languages, so it's not in all the languages. But in Java, it is defined this way. Usually. Then we go to access modifiers. Okay, I think today we will finish earlier because I will need to share the repositories with you, so I'll need to set up, and I'll set up it today after the lesson, so we'll finish a little bit earlier today. So this will be the last thing for today. The access modifiers in Java. Before when we declare the variables and the methods inside the classes, and also the classes themselves, we need to provide the access modifiers to define the scope of visibility of the methods and the attributes. And based on the access modifiers, we can provide the scope of visibility for the variables and the methods in the class. Yeah, so here you can see the table. I previously also shared these tables here. So yeah, based on the access modifiers, we have 3 modifiers which we write, private, protected, or public. If we provide nothing, then it means that this is default. And based on these keywords, the variables and the methods can be accessed differently. Okay, I think for today we can finish. I will share the repositories with you, but you please also share your repositories with me. Create one repository. You should create one repository, GTM, that's for your project, where you will place all your home tasks, and you will share these home tasks with me, right? So please share the repositories, and right now I will share mine repository with you, so you can also access it. Alright, so thank you very much for today, and see you tomorrow then. But not tomorrow, but on Friday. Bye.